Hi, our Day 5 lesson actually started in class today. We took a look at Geometer Sketchpad, which is just another program that we can use in geometry, and we tried to figure out what was the minimum amount of information that we could use in order to prove triangles congruent. Again, we don't want to always have to show that we have 3 pairs of sides that are congruent and 3 pairs of angles that are congruent in every single proof that we do. So again, what we did today in classes is try to figure out what we could use that would guarantee that triangles were congruent. So, on the second page of your document, again, just review quickly. Triangles are congruent if they are exactly the same, which means that corresponding angles are all congruent and corresponding sides are all congruent. So again, you should have 3 pairs of angles that are exactly the same and 3 pairs of sides that are exactly the same. It says sometimes you can prove right triangles congruent using the methods that we talked about in class. Side, 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 angle, or angle, angle, side. Okay, those are the ones that we saw in class today that actually will work all of the time and guarantee that our triangles are congruent. And sometimes you can prove right triangles congruent using one of those methods, but sometimes you cannot. So, there is a 5th method called hypotenuse leg, but you can only use that when you have right triangles. The only triangles that have a hypotenuse are right triangles. So, really, we can use angle, side, side, but only on a right triangle, and we call that rule hypotenuse leg. There's still no swearing in math class. Okay, so again, 5 shortcuts that work. We have side, 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 angle, side, angle, side, angle, angle, side, and those 4 will work with any triangle. And then we also have our 5th method, which is hypotenuse leg, but you can only use that with right triangles. Okay, so what I want to do next is actually go through and do a couple of these proofs with you. We'll start fairly easy, and then we'll work our way up to ones that are a little bit more difficult, and then the next 2 days in class we will just practice making sure that you truly can write one of these proofs. So the next page of your document, we have a proof. Again, we're given some information, there's a picture, and there's something that they're asking us to prove. Now, I did say that we're going to start off really easy. You're pretty much guaranteed to not ever see a proof that is this easy, but again, just to start with, I wanted to make sure that you see where all this stuff comes from. So what I'm going to do is actually write some of this stuff on paper. If you want to do the proof on your calculator, you can. If you want to grab a sheet of paper and copy everything down, the givens, the picture, and what they ask you to prove, that's fine too. Sometimes that can be a little quicker. Alright, so what we have here are 3 givens. We're told that A, B, and D, E are equal, so I'm going to mark those congruent. I'm also told that angle B and angle E are congruent, so again I'm going to mark those congruent. And then I'm told that BC and EF are congruent. Now, one thing I just want to mention, notice that I use this 1 dash mark to match up the first pair of sides. Well, I now have a second pair of sides, BC and EF, and I want to mark those congruent, so I'm going to use 2 dash marks. If I had a second pair of angles, I would use 2 of those arcs, and then I would know which sides and which angles match up. Okay, so those are all of our givens. Now, think about what we have to use. We have 5 methods: side, 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 angle, side, angle, side, angle, angle, side, and we have hypotenuse leg that we can only use with right angles. Now, first thing I want to do is just get rid of things that I know we aren't going to use. In this problem, it does not say anything about a right angle, so we're not going to use hypotenuse leg. If I look at the information that I have 2 pairs of sides and 1 pair of angles. So again, I have 2 pairs of sides and 1 pair of angles. So I'm going to scan through my choices and see which one uses 2 pairs of sides and 1 pair of angles. Well, not that one. This one does, 2 pairs of sides and an angle. This one does not. That one does not. So I'm down to side, angle, side. Now, to write this up, first thing that you want to do, like always, is start off with your chart, your statements on one side, reasons on the other. And just like every other proof we've done, we put in our givens. Now, what I usually do when I'm doing a congruent triangle proof is I make sure that I have everything that I need. If I'm using a method called side angle side, in my proof I have to show that I have two pairs of sides equal and one pair of angles. So I end up with three statements showing that I have things equal. So this first statement right here is a pair of sides. This second statement right here has an equal sign. That's a pair of angles. And my third statement right here is another pair of sides. So if I'm trying to use a method called side, angle, side, I have to have those three things in my proof. Then I can say that the triangles are congruent, and my reason is side, angle, side. Alright, so again, that one was probably too easy. So let's take a look at the second one. Alright, so on this one, we're told that AE and EC are equal. So that's the first thing that I'm going to mark on my picture. AE and EC. I'm also told that E is the midpoint of BD. So if E is the midpoint of BD, that tells me that BE and ED are equal. Now, here's the tricky part. At this point, I'm out of givens. I'm out of givens and I only have two things on my paper. Well, there are a couple of secret weapons. So, really quickly, when you run out of information in a proof and you still need to find something else to use, there are two things to look for. First is look for vertical angles. Okay, if you have lines that intersect and you have angles across from each other, those are equal. They don't have to tell you anything about them. If they are intersecting lines, the angles across will always be equal. So that is something that you can use when you run out of information. The second piece would be, can you use the reflexive property? Remember that the reflexive property says that something is equal to itself. Now, when you use something like this, it's normally when you have triangles that share a side. Maybe something like this, and they have this side in common. We can say that that side is equal to itself without having to have any extra information. Okay, so if we look at our secret weapons, we do have vertical angles. And so that gives us three pieces of information. Now again, we have to figure out what method we're going to use. So off to the side, we have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Alright, so again, we have two pairs of sides and one angle. So it's not that one, could be that one, not that one, or that one. So again, this one will be side, angle, side. So to write up the proof, again, first thing you want to do is put your chart on your paper and then put your givens in your proof. Once you have the givens in your proof, then you can go ahead and use what you know. Well, from this given, E is the midpoint of BD, we knew that BE was equal to DE, so that would be my next statement. And the reason that I know that BE is equal to DE was because of the word midpoint in my given information. Then I had to look at my secret weapons and see if there was something else that I could use. So I had vertical angles, BEA and DEC, so that would be my third piece of information. Now at this point I think I have everything in my proof, so I can say that the triangles are congruent, but I want to make sure. I want to check. So what I'm going to do is skim through my proof and make sure that I have three things: a pair of sides, a pair of angles, and another pair of sides. So right here is an equal sign. That shows that I have a pair of sides equal. There's no equal sign here, so I can't use that. Here I have another pair of sides, and here I have a pair of angles. So I do have the three things: pair of sides, pair of angles, pair of sides. Notice though that they're not in the exact order. On the first one we had a side, then an angle, then a side. They don't have to be in the exact order in your proof. All that you have to keep in mind is that those three things have to be in your proof somewhere, but they don't necessarily have to be in the order side, angle, side. The order comes from your picture. In your picture, you have a pair of sides, then a pair of angles, then another pair of sides. So as you work your way around the picture, you have in order sides, angles, sides. Alright, the last proof that we're going to do for today, we are given that Fn is the perpendicular bisector of OE and that ON is equal to EF. Now, what I've done already is marked up the picture. This part right here, FN, is the perpendicular bisector of two things. Perpendicular means 90 degrees all around, and bisector means cut in half. So, I have my two triangles, and if FN is the perpendicular bisector of OE, then that means that there are 90-degree angles all around angle G. Then the bisector part. Well, bisector means cut in half, so FN bisects OE means that OG and EG are equal. So that's a pair of sides. And then they tell us that ON and FE are equal. So now, if we take a look at the proof, if I start on this triangle here and work my way around, this is an angle, then I come to a pair of sides, then I come to another pair of sides, and we saw that that is not enough information to prove that the triangles are going to be congruent, unless we have right triangles. So, since these are right angles, we can prove that the triangles are congruent using hypotenuse leg. Alright, so how do we write that up? Well, again, we start off with our given information, and then we take a look at the stuff that we are given and see how we can use it. Well, FN is the perpendicular bisector of OE. That tells me that OGN and FGE are right angles. The reason I know that is because that's what perpendicular means. Now, if they're right angles, that means that they're equal. So the next thing that I can say is that those angles are equal because all right angles are equal. The other part of that first given is the bisector part. The bisector part tells me that OG and GE are equal, and that again, that's bisector. And then that's enough to say that the two triangles are congruent using hypotenuse leg. Now, a couple of things. I've told you to mark up your proof as you go through with the three pieces of information. So to use hypotenuse leg, you have to show that you have a pair of legs equal. That would be the OG and EG. So this right here is a pair of legs. You have to show that the hypotenuse of one triangle is equal to the hypotenuse of another. That was actually given to us. And the third piece of information is that you still have to show that you have right angles that are equal. So in here, those are our right angles that are equal. So we have everything that we need in the proof, so the proof is complete. Again, tomorrow in class we'll just practice a few of these, and then the next day hopefully we'll have a little bit of time in class to work through the packet and get a little bit better.